So today we're going to start our unit on graphing quadratics. And to me, besides using the calculator, so I guess that would be an option number 3, there's going to be 2 options we've got for graphing these. And they're probably going to look kind of familiar to some things we've done before. So this is my generic form of a quadratic. Looks kind of familiar, or at least it should look kind of familiar, to something else we just got done with, an absolute value equation. Except now we got parentheses and a squared. My vertex, or my center, is still at opposite of h and k. It's nothing different. So as far as that goes, that's nice. We've got some experience with it. We've also got experience with what the shifts are going to mean. It's the same ones as it has been over and over. Left and right in the parentheses, opposite of what we'd think. Plus k on the end, up and down, we keep the sign. But we do have a new piece to the puzzle here called the Axis of Symmetry. Now, once we start graphing, I'll show you what that is. It's just a line that we draw in, and it's the x value of our vertex. So, graphing. Okay. Option 1. Parent graph. Oh, we've heard this before. Parent graph with a shift. Okay. So our parent graph, when we're doing y equals x squared, I'm going to grab a calculator so you can see this in advance, looks like this. Or if we were in what's called vertex form, it may look like this, but we know that x minus 0 is just x. Adding 0 really doesn't change anything. So these are one and the same. But the question may be, where are these parent points coming from that I'm choosing to use this time? Because before we've had perfect squares, perfect cubes to use. Now it just looks kind of random. You're like, okay, -2, -1, 0, 1, 2, why'd you choose those? Which is a legitimate question. And here's my answer. So if I go, oops, don't want that. Let's try again. If I just graph x squared, you'll hear me talk about this a lot when we're graphing with parabolas. I always want to find my vertex because it's the centerpiece of my graph. It's where everything starts. So with a parent graph, I don't go left or right any. I don't go up or down any. So my vertex, my centerpiece, is at 0, 0. Because what I do then is I see the same numbers above and below that point. It's called symmetry. And so if I'm going to start at 0, I want some numbers to the left. -1 and -2. I want some numbers to the right. 1 and 2. So that's why if you're going to parent point, I always use those. And it's easy to remember because they're right in order. The y column, just like we've had before, is just plug this in. So this is really just going to be x squared. If I take -2 and I square it, in parentheses, the parentheses, got to remember those. -2 times -2 is 4. Okay, -1 times -1 is 1. 1 times 1 is 1. 2 times 2 is 4. And I get this curve, this thing called a parabola. So here's how this is going to work. So let's say we get an example here like this one. Okay, so y equals x plus 3 squared plus 2. Okay, first thing we always want to find is the vertex. So let me pull this back down for just a sec here so we can see. Again, all I'm going to do is steal it straight from the equation. I take the opposite of h, so the opposite of 3 is -3. Bless you. And then plus k just means we keep that value. So we're only changing the x number. So that's going to tell me where the center of my graph here is momentarily. Now just stay with me. Yep, we're only changing the x value around. The y value, we're going to keep exactly the same when we're doing our vertex. But here's what I want you to look at. What 2 directions are my shifts on this one? 2, I'm with you there. This one? Yep, opposite of what we'd think is going to be left 3. So there's a couple of things for me to take into mind with this. If I'm going to do my parent graph, okay, so my parent graph, we're not messing with anything. We're just going to plot these points. So I'd plot 0, 0, negative 1, 1, negative 2, 4. You're like, okay, it kind of looks like that. We're not going to connect them just like we did it when we did it with the radical equations. Parent points we just have there for a purpose, and here's the purpose. I'm going to take them all now, and I'm going to shift all of these left 3, oh boy, and up 2. Left 3 and up 2. Left 3 and up 2. Up 2. Left 3 and up 2. And here's what I want you to take special note of. Okay, here was my vertex, okay, my parent graph, my centerpiece. When I went left 3 and over 2, I ended up at the point negative 3, 2. So it's kind of my double check. It's like, hey, that's my new centerpiece, okay? That's where my graph changes direction. It stops going down, starts going up. So I can tell by the directions I move my vertex. I can wait until I've made the shifts and then look. Or I can take it straight from the equation at the start. All this stuff connects. And so the one last thing I need when I'm doing these is this thing called the axis of symmetry, which is the easiest thing ever. It's x equals, it's an equation. X equals, and just the x value of your vertex. So my axis here would be x equals negative 3. And it's a vertical line that goes through the middle of my graph, through the vertex. And what an axis of symmetry does is it just shows me, hey, if I were to pick up my paper right now and fold it on the dotted line, I'd see the exact same things on both parts. We had done that with like art projects and things when we were younger. So that's the stuff I'm looking for, okay? A vertex and kind of shift. Now again, that's with a parent graph, and we want to do one more, and we'll get you another option. And again, even if you wanted to with this, I'll even mention this. I shouldn't pretend like it doesn't exist, because it does. If I wanted to put this in my calculator, maybe I want to double check, maybe I'm just more comfortable that way. So I mean, I'll take a look here first. Looks like the one I did. And here's going to be your thing. If you know where your vertex is, okay, and you can find that before you do anything else, get that in the middle of your chart, and then check out the numbers around it. Negative 4, 3, right here. Negative 2, 3, right here. Negative 1, 6. Negative 5, 6. Okay, I can find those points. Once I've got the center, then just take a couple on each side, and you'll see the symmetry, and you can make your graph that way too. So I guess we'll call it option 3 or option 1.5, whatever it happens to be. One twist, though, with these. What happens if there's a number in front? What happens if I have an a value that isn't 1? Well, we would do the exact same thing that we did when we were graphing the quadratics, for those of you that were parent graph people. My x values wouldn't change. Okay? My base numbers will always be the same. Because again, this is really just x squared, okay? But if there's an a value, what we used to do before is we would multiply all the y values by that number, in this case 2. So we're going to multiply the 4, the 1, the 0, the 1, and the 4 by 2. Okay. Again, parent points. If you're using the calculator, what I'm going to show you after this, you wouldn't do this part. So negative 2, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 0, 0, 1, 2, and 2, 8. Again, parent points don't get connected. And so then what I would do to get my actual graph is I got to do the shifting. So what shifts do I have this time? Okay, right 1, down 2. So again, I would take all of my points. Right 1 and down 2. Right 1 and down 2. Right 1 and down 2. Well, that's right on there. Right 1 and down 2. And so now, I got lots of ways I could write what my vertex is. I could look at it right there and say, there it is. 1, negative 2. I could have looked at my equation and said, ooh, opposite of h is 1. Keep that, it's negative 2. Lots of ways to be able to do this. Okay? Or again, I can go back to the chart on the calculator. They all work. And then the last thing is my axis of symmetry, which always is an equation, always is x equals, and always is the x value of my vertex. So parent graph with a shift is always an option. Okay? And some of you liked the parent graph before, so I was like, okay, we'll introduce that again. Kind of make a connection here, make it a little bit easier. What if you weren't a fan of the parent graph? You're like, I do not need one more thing to memorize, Harty. Just stop it already. Okay? The other option, besides the calculator, is something we call the 1-3-5 pattern. Okay, still a pattern, but a little something different. No tables involved. So here's how that would work. I get an equation. First job, find and plot the vertex. So what's my vertex going to be this time? Negative 3, 2. Opposite of h. And k. So negative 3, 2. So here's how this works. 1, 3, 5. You're like, okay, where's this coming from? So once I've done that, now I'm going to go up 1 and over 1 in each direction. Up 1 and over 1 in each direction. All right. Then when I get done with that, I'm going to go up 3 and over 1 in each direction from those 2 points I just made. So up 3 and over 1. 3 and over 1. Now to be honest, that's probably enough for you to make a quality graph. But just in case you have room, okay, go up 5 and over 1. 1, 2, 3. Like I said, after 3 we're probably good. 2, 3. And I still do my axis of symmetry just like I did before. Steal the x value from your vertex. Now, this is the exact same one we did for example 1 on the front. So it's just another way of you seeing the one we did with the parent graph. But again, and I'm just going to stress that again here. If you're not sure at the start, okay, there's nothing wrong with not being sure at the start. It's the same equation we had here. I'll pull the chart back up. But just notice the y values, okay, from my vertex. Up 1 gets me to 3. Up another 3 gets me to 6. Up 5 gets me to 11. That's the pattern that you're going to see even in the calculator. So if you don't like doing charts and stuff, this is your fast way of going. And just like the other ones, the only twist is going to show up if there's a number in front. Okay? If there's a number in front, we have to make an adjustment. It's not going to mess with my vertex, though. What's my vertex on number 2 here? 1, negative 2. You're like, it's just like the one on the front, Harty. Oops, I'm not even on the picture anymore. Hang on here a second. Okay. 1, negative 2. But this time I have an a value. Okay, there's a number in front of the parentheses. It's 2. Whenever your a value isn't 1, if you don't see 1, you're going to multiply your 1, 3, and 5 by it. So, here, instead of going up 1, 1 times 2 is 2. So I'm going to go up 2 and over 1 in each direction. And then normally it would be 3. I have an a value. 3 times 2 is 6. So I'm going to go up 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Now I'll do the math on the last one, but I'm not going to do it because this is getting to be overkill. Here, if I had room, I'd go up 10 and over 1, but yeah, that just, that's a little too over the top. So, just again to show that I have options. We like options. Well, I like options. I can only speak to myself, I guess. So I look at my graph. Looks like it comes down below a little. I'm feeling good. I pull my chart. My vertex is 1, negative 2. So I want to get 1 in the middle of the chart. Here's 1, negative 2, and I see my symmetry. Negative 2, if I go up 2, I'm at 0. Yes, I am. At 0, if I go up 6, I'm at 6. It's the same points. Connect the dots. Get my axis of symmetry in again. Come back over. Just stealing from the good old x value of the vertex. And I'm good. So your job, and why I had you grab the extra sheets of graph paper, I don't know how big some of you are going to graph. Not a monster assignment, I know, it's the book. I know. We'll be back to worksheets on the next one. But 5 problems, and again, try the options out, see which one you like. And then that way, hopefully, when we see this again the next time we get together, you can go, okay, I'm a parent graph person. Well, I'm a 1, 3, 5 person. And we just roll with this. Because if we get this down, it's going to make this unit super easy. So work on those 5. Do grab a book or take a picture, do something, and try these out. And we'll see them again next time.